Hello friends, welcome back. Hearty welcome to you. Let's look at this interesting example related to arithmetic series or arithmetic progressions. The houses in a row are numbered consecutively from 1 to 49. Show that there exists a value of x such that the sum of numbers of houses preceding the house numbered x is equal to the sum of numbers of houses following x. So the condition we have been given is that they are saying that there are houses starting from 1 to 49. They are actually in arithmetic progression. So the number of houses is like this: 1, 2, 3, 4, 5, 6, like that up to 49. So there is a house number in between 1 to 49 such that the sum of all the house numbers before that x is equal to sum of all the house numbers after x. So see here, now x is not considered. We are taking all the sum before x and equating to all the sum after x to the end. So to understand it better, what we will do, we'll try to put small numbers there, 1, 2, 3, 4, and try to put the diagram and see what is the condition given to us. Then we will use arithmetic progression sum of the terms Sn formula to solve this problem very easily. Now we have just kept the houses 1 to 49 in that order. So the condition given is that sum of all the number of houses which are before x is equal to sum of all the number of houses which are after x. That means if I start from 1 and go to a number before x, that is x minus 1, the sum of all these numbers, let us say if this is equal to s, then that is also equal to sum of all numbers following x. So I have to start from x plus 1 and I have to go till end. Let us say this sum is also equal to s. So these two are equal. Now we have been given that sum of all the house numbers starting from 1 to the number preceding x, that means x minus 1, is equal to sum of all following x, that is x plus 1 to 49. Now we will use arithmetic progression sum of n terms formula. The formula says that sum of n terms in arithmetic progression is given by n by 2 into, we will be using this formula, so 2a plus n minus 1 into d. Now in this particular case we know that a starting number is equal to 1 because we are starting with 1, and the common difference is also equal to 1 because 2 minus 1 is equal to 1. So let's try to substitute a and d values and try to get an equation here, get a formula. Sn equal to n by 2 into 2 into a, that's equal to 2 into 1, plus n minus 1 into d, that's equal to 1. If I simplify, I will have n by 2 into 2 plus n minus 1, which is equal to n into n plus 1 by 2. And you know, this is the same formula we used to find out the sum of n natural numbers. Sum of n natural numbers starting from 1 is nothing but given by n into n plus 1 by 2, and the houses are also given to us are natural numbers and also they are consecutive. So same formula holds good. So the formula which we are going to use now to find out the sum of n terms in this particular problem is, we'll just write it down here, s of n equal to n into n plus 1 divided by 2. With that, let's go back to the problem and try to equate the sum. So sum s is nothing but equal to sum of 1, 2 terms up to x minus 1. This is nothing but given equal to sum of terms are nothing but house numbers from x plus 1 to 49. This is what is given to us. So sum of 1 to x minus 1 equal to sum of x plus 1 to 49. So sum of 1 to x minus 1, directly we can apply the formula because we are starting from 1, we are going to x minus 1 terms. I can write down sum of x minus 1 is equal to, now here I have a problem, sum of x plus 1 to 49. Sum of x plus 1 to 49 is starting from x plus first term, but we always know s has to start from a equal to 1 only. So what we will do, we'll try to manipulate this and write it as, what I will do before that, I'll start from here and see if I go till end, this is nothing but sum of 49. So this is equal to sum of all 49 terms, and from that if I am able to subtract sum up to x terms, that is nothing but equal to sum of x plus 1 to 49. So you can see that now s of x plus sum of x plus 1 to 49 is equal to sum of 49. So I can write sum of x plus 1 to 49 as sum of 49. Can I write it as sum of 49, all 49 terms, so that I am starting with 1. Subtract from 1 to x. When I subtract it, I am left out with only s. So s is nothing but s of 49 minus of s of x. Now we know the formula for this. Directly we found out the formula, so let's substitute that. Starting from 1, x minus 1 terms, n equal to x minus 1, so it will be x minus 1 into x minus 1 plus 1 divided by 2 is equal to 49 into 50 divided by 2 minus s of x, that's equal to x into x plus 1 by 2. We can use this formula straightforward because all these three arithmetic progressions whatever we are seeing, all of them are starting with 1 and with a common difference of 1. A equal to 1, d equal to 1. So we can leverage this formula. So let's go ahead and write the next step. X minus 1 plus 1 will cancel. So can I say x into x minus 1 divided by 2 is equal to 49 into 50 divided by 2 minus of x into x plus 1 by 2. The first step I do is multiply with 2 throughout. So I will have x into x minus 1 is equal to 49 into 50 minus of x into x plus 1. Now we will get x into x plus 1 to left hand side. We will have x into x minus 1 plus x into x plus 1 is equal to 49 into 50. So now we see that we can take x common in both of them. So I will have x into x minus 1 plus x plus 1 equal to 49 into 50. We'll simplify that. We will have minus 1 plus 1 cancels. We have 2x square is equal to 2450. So you go to the next step, we can write it as x square equal to 1225, or x equal to square root, taking square root on both sides, we have x equal to 35 because minus 35 cannot be considered. So the answer is the x value is 35. Now let's verify this and check. So what we are saying now according to this formula, x is 35. So we are saying s of 34 is equal to s of 49 minus s of 35. Let's verify this. What is s of 34? 34 into 35 by 2 is equal to s of 49. 49 into 50 by 2 minus s of 35. 35 into 36 by 2. So let us check LHS is equal to RHS. 2 we can simplify this. We have 595 equal to 225 times. So I have 1225 minus 630. So we can see that 1225 minus 630 is also equal to 595. So we have verified that the solution we got is correct. So the x value is equal to 35. That means in between 1 to 49 there is a house number 35. You just go before 35 up to 34. So 1 to 34 you add all the numbers. The value of that is exactly equal to, go to 36 after 35. From 36 you go to 49. Add all the values between 36 to 49. So those sums, both of them are equal. That's nothing but equal to 595. So the x value is equal to 35. So let's summarize this. The houses in a row are numbered consecutively from 1 to 49. Show that there exists a value of x such that the sum of numbers of houses preceding the house numbered x is equal to sum of number of houses following x. So what we will do now, we'll just keep in number 1 to 49 we have been given, and they are going in consecutively 1 2 3 4. So there is a value where there is a number between 1 to 49. We have to find it out. So let us say that's equal to x. They have already given us that it is x. So x before number is x minus 1, x after number is x plus 1, because they are consecutive natural numbers. So 1 to x minus 1, you try to find out the sum of them. That should be equal to sum of x plus 1 to 49. But sum of x plus 1 to 49 is difficult to find out. So we have manipulated it and we have written it as sum of x plus 1 to 49 is nothing but equal to sum of 49 minus sum of x. Now we can directly use the formula n by 2 into 2a plus n minus 1 into d, or if I put a equal to 1, d equal to 1, it becomes n into n plus 1 by 2. So I can directly substitute the formula and we can find out the value of x. So that's an interesting example which is given in recent CBSE 10th class exam 2016. So I'll catch you once again with another interesting example. Thanks for your time and support. Bye for now.